This is a surface map for 6:43 a.m. Central Standard Time, November 17th, 2013. This was an extremely strong low-pressure system that moved through the Midwest. The winds were very gusty, very strong ahead of the front and also behind the front. The upper level dynamics had the same situation where the winds were extremely strong from the bottom surface all the way up to the top of the atmosphere, which actually primed the atmosphere perfectly for a lot of severe weather. You can tell what the front is. And here's Kansas City, so it's 6:43 in the morning. The front had not passed through. Notice the winds are still very gusty and strong. Topeka, the winds are out of the southwest. If you keep going west and get to Manhattan, the winds are out of the west-northwest. So the front sits somewhere along this corridor as of 6:43 in the morning. So finding a front, you can look at it in terms of wind direction. You can also look at it in terms of temperature, if there's any temperature differences, and in this case you can do the same thing if you just look at the temperature difference. It's 51 in Manhattan at 63 in Topeka. So at 6:43 in the morning it was pretty warm this morning, and as that front moved through, it obviously dropped the temperatures quite a bit. So there's two ways, looking at the temperature or looking at the wind shift. The wind shift is typically a lot easier unless it's a strong cold front, then the temperatures could be just as strong. You could also look at it in terms of moisture content, so which side has lots of moisture and which side has very little. So there's three ways you can pick out a front on a map. Now this is 9:43 in the morning, the same date, and the front has moved through the Kansas City area. It's through Sedalia, and you can see just where Columbia is, it had moved off to the winds are out of the southwest, so the front is now lying somewhere along this area. So 3-hour time span, it moved from Manhattan all the way through to almost mid-Missouri. This is 2:23 p.m. Central Standard Time, and Missouri, I've shifted the view a little bit because the front's out of the other view. So here's Missouri, and now see if you can't pick out where the front actually is. Get it in terms of the wind shift, and you can see where the winds are out of the west versus out of the southwest, so the front is somewhere in parts of Illinois, in the lows all the way up towards the Great Lakes. So three good ways to look at how to find a front on a surface map. Also, when you're looking at once you find where the front is and then low pressure, keep in mind the low pressure is up here. That's why your winds are southwest ahead of the front, and why your winds are to the west northwest behind it, because you got that counterclockwise flow. Ahead of the cold front is that warmer air. And again, you can see that the difference between the warmer air really isn't a huge difference in this case, but it can be a very large difference. There's a lot more moisture ahead of the front, and you can tell that easily by picking out one station. The temperature 64 and the dew point 63, so it's extremely moist on this side. If you go behind the front, let's go to one we can see real easily, south of Sedalia, Missouri. Temperature is 70. The dew point's 30, so the bigger spread between the two numbers, the drier the air is. So you get that cold polar air mass, that they call a continental polar, a colder, drier air mass behind the cold front, and the maritime tropical, warmer and more moist ahead of the front.